Now we discuss mathematically the analytical treatment interference of waves. So just to imagine that it's a y1. Let y1. y1 is the displacement of medium particle. So with respect to time, y1 is equals to a1 sine omega t. So it's what? Same angular velocity is omega. So this is my first condition, is displacement of, it's a displacement of first particle, displacement of first particle in a medium. So first particle in a medium. So similarly, so I'm talking about this is second particle in the same medium, the particle of another wave of same angular frequency y2. y2 is equals to a2 sine omega t minus phi. It lags with a phase. The phase difference is phi. Okay. Now the resultant displacement of this medium particle. Okay. So the resultant, what is the resultant displacement? Resultant displacement of medium particle. It's a medium particle. So what is the resultant displacement of medium particle? So already we discussed about superposition of waves, okay, for the constructive interference and destructive interference. So first, from these two, both of them traveling in the same way, but if they have the initial constant phase, y is equals to y1 plus y2. Actually we need to write y1 bar plus y2 bar, but both are in the same direction. So vectorially I am writing as this. So need not to write vectorially, directly y is equals to y1 plus y2. So this is y1 is a1 sine omega t plus a2 sine omega t minus phi. Okay, this is what resultant displacement. Now you expand this. Just we need some patience for solving this. Carefully do this. a1 is a1 sine omega t plus a2 times of sine omega t cos phi minus cos omega t sine phi. Okay, so this is, this y is equals to, so I'm taking as from the first one is that a1 sine omega t. So now this is a1 sine omega t plus a2 sine omega t cos phi minus a2 cos omega t sine phi. Yes, so this is y is equals to, okay, it's what, a1 sine omega t, a1 sine omega t, sine omega t, here sine omega t is common. So this is y is equal to, sine omega t is common, this is sine omega t, a1 plus a2 cos phi minus a2 cos omega t sine phi is the resultant displacement. Just you take on this. First one is this. This is a1 plus a2 cos phi. Next one is a2 sine phi. Yes, it's a a2 sine phi. Just you consider. So a1 plus a2 cos phi r cos theta. Okay. So next one, this is r sine theta. So it's a r sine theta. So now just you make the equations. Now r cos theta is equals to a1 plus a2 cos phi. Okay. Next one, r sine theta is equals to, so it's a a2 sine phi. So these are the required equations. So from this, now while substituting this, we will get it as y is equals to r. Okay, so from this I'm talking here. So here is the condition, y is equals to, so a1 plus a2 means what? R cos theta and sin omega t. a2 sin omega t sin phi. So you can write it as R sin omega t minus phi. Yes, sin A cos B minus cos A sin B. Okay, so this is the equation for what? You can observe this one. The equation, it indicates what? Simple harmonic motion. Okay, SHM. So the particle, now we can state that after the superposition of two waves, after the superposition, so after the superposition of two waves, after the superposition of two waves, so the medium particle, so the medium particle executes SHM, simple harmonic motion. Now we can find the resultant displacement of the particles. Okay, so the displacement means what? Which we got the equations from this. So for first one is here, R is equals to, that's what? R cos theta is equals to A1 plus A2 cos phi, and R sin theta is equals to, so it's a A2 sin phi. So just to treat it as, it's what? Let it be equation number 2, and next one is equation number 3. From the equations 2 and 3, okay, from the equations 2 and 3, so first one is squaring on both sides and adding them, then you will get it about, so R square cos square theta plus R square sin square theta is equals to A1 plus A2 cos phi whole square plus A2 sin phi whole square. So this is A2 sin phi whole square. It means R square common. So sin square theta plus cos square theta is 1. R square is equals to, so A1 square plus A2 square cos square phi plus 2 A1 A2 cos phi plus A2 square sin square phi. Okay, so now R is equals to under root of, now we can go for this, A2 sin square phi, A2 cos square phi. So this would become as A1 square. A2 square common means for sin square theta plus cos square theta is 1. It's a A2 square plus 2 A1. Next one is A2 cos phi. Okay, so is a way to find about resultant displacement of the particle after superposition. Same like parallelogram law of vectors. So angle made by the resultant, with A2, okay, with A2. So this is first one, A2 sin phi, right? So now we can talk on this, means what? Like a parallelogram law of vectors. This is first vector, okay, next second vector, it's for example A bar, this is B bar, parallel to this draw a vector, it's A bar. So next one is, this is parallel to this one, it's a B bar. So this is what is, it's a resultant, it's a R bar. So this is what? Alpha. So if you extend this one, it becomes as like, this is B cos, okay, B cos, this is theta, this one also theta, B cos theta. Next one is what? B sin theta. So this B bar is inside. So here, this is the B bar. Now here is extended like B sin theta, B cos theta. Same. So the angle made by the resultant with A2 sin phi. Okay. So that's what? Tan alpha is equals to, okay, A2 tan alpha is equals to, so from this A2 sin phi by A1 plus A2 cos phi is the relation. So now, sir, I want to derive this one. How can I derive? You can derive, so this equations, first one, what is the equation number? So now we have the equation, this is what? R cos theta is equals to A1 plus A2 cos phi, R sin theta is equals to, so A2 sin phi. So this is what, if you divide these equations, Okay, r sin theta equation number 3 by equation number 2. So then a2 sin phi by a1 plus a2. This is the relation. We can also discuss maximum displacement a max is equals to, so it's what, directly a1 plus a2. So it comes from phi, phase difference phi is equals to 0 degrees. So the a is equals to, a means we treat it as it's a r. So this is equals to under root of a1 square means a square plus a square plus 2a1 a2 cos 0 degrees. Both are in the same direction. So this will become as under root of a square plus a square. So plus 2a1 a2 is let it be, it's what, this is what, a1 and a2. So you can write it as a1 plus a2 whole square. Square and root cancel. So this is what, r max is equals to a1 plus a2. If they are traveling in opposite direction, so it's what, minimum amplitude. A minimum is equals to, we can write a1 minus a2. So you would also ask for the ratio a max by a minimum is equals to maximum amplitude of superposition of the waves. Okay, so a max by a minimum, it's what, a1 plus a2 by a1 minus a2.